So just a note on discount rate. We initially set the discount rate equal to the utility's weighted average cost of capital. In reality, these two things, the weighted average cost of capital and the discount rate, are not always the same. So then the question is how to pick a discount rate. One example or one possibility could be the interest rate. That might inform the discount rate, or the money you or someone else could earn on an alternative investment. But also the perceived riskiness of the investment or project. And of course, that's kind of related to the interest rate in some cases. So both of those things matter. But discount rates are also somewhat subjective. So let's prove that. So just as sort of an exercise, let's say you have two choices. Someone comes to you and says, I will give you $1,000 today, or I'll give you some amount of money out 1 year into the future. So, exactly 1 year from today. Then the question is, what number, when filled into the blank for option B, would make you choose that one, right? So for example, would you rather have $1,000 today or $1,000 plus one in 1 year? Probably $1,000 today, because there's a lot that could happen in the next year. And, you're a student, and there's a lot that you could do with that $1,000 today if you had it in your pocket. Lots of fun things to do. You could pay off debt, whatever. But so at some point, everybody kind of has a price, right? So let's say the choice is between $1,000 today and $1,000 plus 100 in 1 year, or $1,000 today or $2,000 in 1 year, or $1,000 today and $5,000 in 1 year, right? So the question that we're trying to figure out for every individual here is how much money in 1 year would you be willing to accept to forego the $1,000 today? And so we can find out, we can derive your personal discount rate using this information, whatever value, whatever money, or whatever value you put in for option B, and this trusty equation that we have. So if we say present value is equal to the future value divided by 1 plus r to the t, what's our present value? Our present value, somebody's offering you $1,000 today. So that's our present value. So we can plug that in. The future value is what you're supposed to put in yourself, right? So what's the amount of money in 1 year that you'd be willing to accept instead of $1,000 right now? 1 plus r is what goes in the parentheses, and r is what we're trying to find. That's the discount rate, your personal discount rate. And we know t is going to be equal to 1, because the question is, how much money would you be willing to accept in 1 year? So we can initially fill out this equation as $1,000 is equal to FV divided by 1 plus r to the 1. And then what we can do is multiply both sides by 1 plus r. So 1 plus r to the 1 is just equal to 1 plus r. So the exponent goes away. And so if we multiply both sides by 1 plus r, we get on the left-hand side $1,000 times 1 plus r is equal to FV, so the future value. And so if we then carry the multiplication on the left-hand side through the parentheses, so we say $1,000 times 1 plus r is really equal to $1,000 plus $1,000 times r, so just by carrying through $1,000 through the parentheses, and we set that equal to the future value, then we can solve for r as a function of the future value that you specified for answer B. So we can rearrange that equation to say that the r, or your individual personal discount rate, is equal to FV, which is whatever value you decided would make you wait a year to collect your money, minus 1,000 divided by $1,000. So for example, if your answer to that question was let's say $2,000, if you said that only an amount of money $2,000 or greater would incentivize you to wait a whole calendar year to accept that amount of money, then we'd say $2,000 minus 1,000, so $1,000 divided by another $1,000, just gives you one, or a discount rate of 100%. So depending on what you said, we could talk about what it means, right? So a high discount rate, certainly 100% would be a very, very high discount rate. If you have a high value for R, what that means is that having $1,000 right now is worth much more than having $1,000 in the future. In other words, you put a tremendous amount of value in having money in hand right now. A low discount rate, a low value of R, would mean that having $1,000 now versus in the future are relatively equal in value. In other words, it doesn't matter to you as much about having $1,000 now or having it sometime out into the future. You would require less money a year from now in order to forego that, having that $1,000 today. So in a slightly more abstract sense, natural resource extraction rates are actually thought to be a reflection of a society's discount rate. So it gets at the same question: how much do we value the present, and how much do we value the future? So this relates to the reading that I assigned for this class, discount rates for otters. So first question here is, how does the discount rate from that article, how does the discount rate impact the future costs we associate with climate change? So if we have a high discount rate, what does that do to the future costs of climate change? Well, it discounts them more. If you have a really, really high discount rate, whatever comes out into the future, whether that's a lot of earnings and revenues or a lot of costs, become less important. A low discount rate would mean that we basically value the present and the future the same. So that would assign a greater value to the potential future impacts of climate change. The second question here is, what types of countries do you think might be more likely to have a high discount rate? In other words, to discount the future costs of climate change, to view them as potentially less important when it comes to dealing with that challenge. And this relates back to one of the first things we talked about this semester. This is a slide that we saw in the first lecture, and this is the environmental Kuznets curve. Remember, on the y-axis, it's some sort of measure of environmental degradation, for example, carbon emissions. And on the x-axis, we have stage of economic development. And remember that the sort of historical, conventional trajectory was for countries to initially develop at the expense of the environment until they reach some sort of inflection point. And then they're able to develop wealth and develop economically while polluting less. And so that's what happens after they reach this turning point. So if we just think about which countries, pre-industrial economies or post-industrial economies, would you associate with a high or low discount rate? And so the answer is that the pre-industrial economies, we would typically say, have a higher discount rate. And that's because they are trying to acquire wealth immediately, right, to solve more basic challenges or meet more basic human needs like water and sanitation and education and lifting people out of poverty. And so the viewpoint there is that countries with higher discount rates may in some ways value the potential consequences of future climate change less heavily. And that's because they simply have bigger fish to fry, in more immediate bigger fish to fry in the short term. Countries that are post-industrial, that have more of the basic requirements for sustaining a population economically met, might have lower discount rates. In other words, post-industrial economies might view the present and the future on more equal footing in terms of dealing with the potential impacts of climate change. And what that means is that they would weigh the potential impacts of climate change more heavily with a low discount rate.